Today's lesson is on stoichiometry. So stoichiometry will use dimensional analysis a lot. If you feel like you don't understand the stoichiometry as much, or you know that you need a refresher on dimensional analysis, please go to the dimensional analysis video. So stoichiometry uses a balanced equation to solve a word problem or to find the expected yield in a lab. So first and foremost, your equation has to be balanced. If it's a problem that I'm giving to you, I will give you an already balanced equation, but you may have some textbook work that requires you to first balance the equation and then to use the stoichiometry. So in stoichiometry, you have a given substance, A, and then you have the substance that you're solving for. This is no different than any other dimensional analysis problem. And I have this chart here because this will tell you how many conversions you're going to have to do in order to solve for your problem. So I'm always going from right to left in some fashion. So if I am given a question where I'm given moles of A and I'm asking for moles of B, then I will just use one co-conversion. If I'm given grams of A and I need to find moles of B, I will have to do this conversion first and then this conversion. So the number of colors that you end up going through are going to be equal to the number of conversions that you will have. So the good news is that no matter how convoluted you are going to have to do your conversions, the most number that you will have is 3. So 3 conversions is the maximum that you will probably have, and usually that will be 3 because in our lab we tend to use grams and liters. Very rarely in the lab are we just looking at moles. So to talk about the conversions, anytime I'm given grams of a substance or I'm looking for grams of a substance, the conversion I will have to use is the molar mass from the periodic table. So that's what this PT means. That's a reminder that I have to use the molar mass from the periodic table, and a reminder that the molar mass is always the mass for 1 mole of the substance. So these numbers have nothing to do with a balanced equation. These are just from your periodic table. I will always have to use this purple set, and that's always my coefficients for my balanced equation. So BE means balanced equation. And then finally, later on when we add gases, we will talk about molar volume. So if I have liters of a gas A, just a gas at STP, or liters of gas B that I'm looking for at STP, then I will use MV or molar volume, which is a very particular conversion, which is 1 mole of gas is equal to 22.4 liters, and that's again at STP. And if you don't know what STP stands for, don't worry about it. We will get to it when we get to gases. So here again is a recap. Each color equals 1 conversion or 1 parentheses. You always write the given units to the far left. The number of conversions or parentheses that you need are the number of colors that you have used. Then you write an equal sign and a space for the amount of B and the units that you are looking for. You insert the units into your conversion parentheses, and you do it in a way that you end up with the units of B needed in the numerator of your last conversion, and then you add the proper numbers and solve. So again, if none of this seems to be familiar, please watch the dimensional analysis video that I created. Hopefully that will clear things up. So here's an example stoich problem. How many grams of Al2O3 can be prepared from 34.0 grams of aluminum combusted with enough oxygen? So again, if you remember from the dimensional analysis video, I know that these are my given units, 34.0 grams of aluminum, because there is a number there. Whenever I give you the number, that's probably the given units. And grams of aluminum oxide don't have a number associated, so that's what I'm looking for. So I set my 34 grams of aluminum here and grams of Al2O3. So I'm given grams of Al is my A, grams of A, and grams of Al2O3 are my grams of B. So if I go back to my chart, so here is my chart, and I have to go from grams of A to grams of B. So I have to go through green parentheses, purple, and then blue. So that tells me that I'm going to need a total of 3 parentheses. This first one is from my periodic table, and I'm converting grams of aluminum to moles of aluminum. Then my second set is from my balanced equation here, and then my third set is from the periodic table to convert grams to B. So I need to make sure that my units cancel out. Grams B, which is Al2O3, needs to be in the numerator of the last parentheses. Well, that means that it can only be converted to moles. So grams of substance can only be converted to moles of a substance. Similarly, at the front, I need to cancel out grams of aluminum. Grams of aluminum can only go with moles of aluminum. That will go my first parentheses. And then in my second parentheses, I'm going to be able to cancel out my moles of aluminum and my moles of Al2O3. So grams A, moles A, moles A, moles B, mole B, grams B. First and third parentheses come from the periodic table. The middle parentheses will come from the balanced equation. Now, I went ahead and put in 1 mole of Al over 27 grams and 1 mole of B for 102 grams of B. I put the 1 in, again, so that when I check my work, I can be confident that my conversions are the way that they should be. Similarly, my 2 and my 4 come from my balanced equation, the coefficients. I could reduce them to 1 over 2, but it is a good idea to continue to just put the coefficients as is from your balanced equation, so that again, when you check your work, you're not simply just plugging numbers that you have into your calculator, because that's not checking your work, but you're actually making sure that your conversions make sense. So if you don't remember how to do molar mass calculations, you can either watch the molar mass video or just remember that I am multiplying the mass of the aluminum by the subscript within the compound. That's where I get 27 and 102. Now, for the most part, you can, when you're doing these stoichiometry problems, just work with whole numbers. So I have my 34 grams of aluminum is what I'm given. I know I'm going to have 3 parentheses to get to grams of aluminum. First one's from the periodic table, and it's going to be for aluminum. Second parentheses, balanced equation, coefficients for my balanced equation. And third parentheses, periodic table for the molar mass of aluminum oxide. I put my units in and remind myself that this is 1, so I don't go calculating 5 moles of aluminum oxide. And now that I'm sure that my units cancel out the way they're supposed to, I'm left with aluminum oxide. Cross these out, cross these out, cross these out. Then I add in the numbers. And then I do what people call magic math, but is just simply 5th grade math of crossing out and reducing fractions. And I end up with 64.2 grams of aluminum oxide. You can multiply 34 times 2 times 102 divided by 27 divided by 4. You need to remember PEMDAS rules. So if you're trying to combine 27 times 4, put it in parentheses. Or you could just simply cross out the way I did and reduce ahead of time so that all you're doing is multiplying 34 times 17 divided by 9 to get 64.2. I hope that was helpful.